So hey guys, today we're going to deal with the topic of logarithms. This topic can become complicated because some students tend to not understand the rules regarding logarithms. So what we're going to discuss today is all the rules regarding logarithms, what the logarithm is, and hopefully this would help better your understanding in the topic of logarithms. So first thing first, we have the definition of the logarithm, okay? We have y is equal to e to the power of x, okay? In this case, x refers to the index, e refers to the base, okay? And y refers to the number, okay? And this is basically how we define the logarithm now. How we define the logarithm is that this is the equivalent of x is equal to log y to base e. So if we have a number in the form y is equal to e to the power of x, we could also express this in the form x is equal to log y to base e, okay? And log represents the logarithm, okay? So that's a very that's how we represent it, okay? um so common things to know about logs is that the most common log basis you will see is log to base 2, log to base 10, and log to base e, okay? E is a very important number, and log to base e is what we call the natural log, okay? Now when we write in this now, because log to the base 10 and log to the base e are the most popular ones, what we simplify these, okay? So rather than write in log to base 10, we could simplify this and just write LG. So anytime we see LG, we know that this refers to log to the base 10. Now, if we have log to the base e, this refers to the natural log, so refer to it as ln, okay? So rather than having to continuously write log 10 or log e, for log 10, we could write lg, and for log e, log to base e, we could write ln, okay? So this basically simplifies it. So we need to understand this definition, okay? So for example, if we have y is equal to 2 to the power of x, okay, we need to be able to convert it from this form to the logarithm form. So based on the rule above, if you watch where all the letters go, okay, x becomes the subject, okay, a becomes the base as it goes down, okay? So this is the equivalent of x is equal to log y to base 2, okay? That is the equivalent of this, okay? So the first example. Next example, if we have, let's say, x is equal to 4 to the power of 5, again using the format we have above, okay, this would be equivalent to saying 5 is equal to log x to base 4, okay? That's the equivalent way of writing it as well. And let's do one more example. Let's say we have 49 is equal to 7 squared, okay? Which is true because 7 squared is 49. This is the equivalent of writing it in the form 2 is equal to log 49 to base 7, okay? And if you type in log 49 to base 7 in your calculator, you will get 2, okay? So we need to be able to know how to convert between these two forms, okay? So in our next example now, let's say we have x now is equal to log y log 6 to base y. Okay, this is the equivalent of writing it in the form 6 is equal to y to the power of x. Okay, so how I tend to think about it, right, when converting from this form to this form, is that you kind of need to know how to do it. So what I do is I just imagine in my head that I'm pushing the y up. Okay, I'm pushing the y up and I'm pushing it here, right? If I push the y there, then this x has to move up. So I get 6 is equal to y to the power of x. Again, this is just my own way of remembering it. Okay, you put the y on the left side and then you move everything up one. So let's see, we have a next example now. We have 3 is equal to log 8 to base 2. Again, we bring the 2 on this side and push the 3 up. So it becomes 2 to the power 3 is equal to 8. Okay, I'll do one more example. Let's say we have 9 is equal to log 2 to base z. Again, move the z here, push the 9 up, so it becomes z to the power of 9 is equal to 2. Okay, that's how I remember it. If it works for you, I hope it does. If it doesn't, well, I guess you just have to memorize it. So the next thing we have to go on to now is the rules of logs. Okay, these rules are very important and you need to know them because these rules are needed to basically do questions on logs. Okay, so the first rule is pretty simple. If we have log 1 to any base, this is equal to 0. So log 1 to any base is always equal to 0. For example, if I have log 1 to base 5, this is 0. If I have log 1 to base e, it is 0. So log 1 to any base is 0. The next rule, log of any number e to e. So basically, when it is the same number, when the base is also the same number, this is equal to 1. Okay, so for example, if I have log 5 to base 5, this is equal to 1. If I have log e to base e, this is equal to 1. Another way of writing this would be ln e. So the value of ln e is 1. Okay, so that's the next rule. Third rule, if we have log x to the some power n to base e, this is equal to n log x to base e. So this rule is commonly referred to as bring down the power. Okay, so basically all we do is bring down the power and put it here. Okay, just as you bring down the power, you could also send back up the power. Okay, so normally whenever we say bring down the power, we're referring to this rule. So for example, if we have log x squared to base 5, this is the equivalent of 2 log x to base 5. Okay, if let's say now we have log 6 squared to base 6, this is the equivalent of 2 log 6 to base 6. And remember, we know that 2 log 6 to base 6, since it's the same number, is equal to 1 based on rule 2. So therefore the answer to this is 2. Okay, so that was pretty simple. Let's do another example. Let's say now we have 5 log x to the base 2. Okay, this is equal to log x to the power 5 to the base 2. So in some cases, you might have to go the other way. Rather than bring down the power, you have to send up the power. Okay, for example, now, let's say we have 4 log 2, 2. So we know this is actually equal to 4, but let's say we want to simplify this log. We'll bring down the power, so we'll have 4 is equal to log 2 to the power of 4 to the base 2. 2 to the power of 4 is 16. So we have log 16 to the base 2. So 4 is actually equal to log 16 to the base 2. Okay, so those are three rules, three very important rules. Okay, so the next rule we want to do now is the summing rule. Okay, so this is rule number 4. If we have log x to the base a and we add in log y to the base a, this is equal to log xy to the base a. Okay, notice for this to work, it needs to be to the same base. If it is not the same base, it will not work. Okay, so basically think of it that when you add in logs, you basically multiply the two parts. Okay, so log x to base a plus log y to base a is equal to log xy to base a. So for example, okay, let's say we have log 2x plus 2 log y to base 2. Okay, now when we're doing this, you cannot have anything in front of the logs. You cannot have anything here and you cannot have anything here. So basically, as you see in this step, we cannot add these just yet, right? Because we have a 2 in front here. So what we need to do is move the 2 upwards. So if we recall rule 3, which we just did, we'll have log x to base 2 plus log y squared, because we bring up the power to base 2. Okay, and now we can add them. Because we don't have anything in front of the logs, we can now add them. Okay, so this would be therefore equal to log xy squared to base 2. Okay, so remember that whenever you add in, you cannot have anything in front of the logs. Okay, let's do our next example. Let's say we have 2 log x to base 3 plus 3 log y to base 3 plus log 7 to base 3. So remember what I said before, we cannot add anything because we have a number in front here. Sorry, because we have a number in front here, so we need to get rid of this number first. So what we do, we recall rule 3 and we basically move the power up. Okay, so we'll have log x squared to base 3 plus log y cubed to base 3 plus log 7 to base 3. Okay, now we can add them because we don't have anything in front of the logs. Okay, so therefore becomes log base 3, and we add and we basically multiply and everything, so it becomes 7 x squared y cubed. Okay, and that's how it works. Okay, remember it needs to be to the same base. Okay, so the next rule now, which is rule 5. So that last rule dealt with addition, so now we have to deal with subtraction. So again, if we have log x to base a minus log y to base a, again remember it needs to be the same base. This is equal to log to base a of x over y. Okay, so just like how when adding you multiply, when you subtracting you divide. Okay, and again the same rules follow for the last one. You cannot have anything in front of the log. Okay, So for example, let's say we have log x to the base 2 minus log y squared to the base 2 plus, no, this is plus sign now, plus log z to the base 2. Okay, so notice we have nothing in front of the log, so we could directly go into multiplying them and dividing them. Okay, so this here now, so wherever we add in we multiply, and whatever we subtract in we divide, so it becomes log to the base 2, right? Notice here now we are adding the x and we are adding, because this is a plus sign in front here, we add in x and we add in z. So what we'll have is xz, and we subtract in the y squared, so it becomes divided by y squared. So we get xz over y squared to base 2. Okay, okay, let's do another one. Okay, another example. If we have log x to base 3 minus 4 log y to base 3 plus log 8 to base 3. Okay, so notice we have something in front of the log, so before we could even think about doing anything, we need to move this 4. Okay, and remember what we're trying to do is get into one simple term. So we'll have log x to base 3 minus log y to the power of the 4 base 3 plus log 8 to base 3. Now remember, whatever we add in, we multiply in, and whatever we subtract in, we are dividing. So it becomes log to base 3 of x, well, 8x actually, let me write it properly, 8x all over y to the power of 4 to base 3. Okay, and that is the fifth rule for logs. Okay, so the sixth rule for logs now, we almost finished. There are only 7. There are more, but these are the ones that you need to know. Okay, log a to base b is equal to 1 over log b to base a, right? And in this case, what we call this is the changing of the base. Okay, so let's say you don't want the base to be b, but you want it to be a. This is how we could do that. Okay, so for example, if I have log 2 to base 8, okay, if I want to make um if I want to make 2 the base, it becomes 1 over log 8 to base 2. And we could actually simplify this, okay, because we know that 8 is actually 2 cube. Okay, so it becomes 1 over log 2 cube. Okay, and we could bring down the power 1 over 3 log 2 to base 2. And remember, we know that log 2 to base 2 is 1, so it becomes 1 over 3 multiplied by 1, which is equal to 1/3. Okay, so as you can see, you realize how important these rules are. Okay, and the last rule now, rule 7, okay, we have log x to base a is equal to log y to base a. So in a case where we have log x to base a is equal to log y to base a, this implies that x is equal to y. Now note, they have to be to the same base, and you can only have one term on the left hand side and one term on the right hand side. And what we call this is dropping the logs. Okay, whenever we do this step, we normally refer to it as dropping the logs. So for example, let's say I have log x to the base 2 plus log x plus 1 to the base 2 is equal to log e to the base 2. Okay, let's say I have a case like this. Okay, what we'll do is, notice we can't drop the logs. A common thing people do is that they drop the logs immediately and they say x plus 1 is equal to 8, and that is wrong. Okay, that is wrong. You cannot do that. What you need to do to drop the logs, you need to have one term on the left hand side and one term on the right hand side. So notice that we only have two terms on the left hand side. So what we need to do is combine these two terms into one. So since we are adding, it becomes log to the base 2 of x, of x into x plus 1. Okay, probably put these in square brackets. Okay, and this is equal to log e to the base 2. Okay, now let's say we want to expand this bracket here now, so it becomes log 2, right? It becomes x squared plus x. Okay, is equal to log e to the base 2. So you notice now we have one term on the left hand side and one term on the right hand side. So this is one term here, even though it's okay if you have a plus sign in within the log, but you cannot have two separate logs. Okay, and what we could do now is we could drop the log. So therefore we could say that x squared plus x is equal to 8. Therefore x squared plus x minus 8 is equal to 0. Okay, and that's the last rule of logs. Okay, so these rules become very important. Okay, and we need to understand how to use them. Okay, so let's say we have a question here. Now I'll just do one question based on this rules that we did. Okay, let's say we have log 12 to the base 3 plus log 4 to the base 3 minus 2 log 6 to the base 3. Okay, and I want you to find the value of this. Okay, let's say let's say we change this actually to 4 over 3. Okay, so we want to find the value of this. If you want to find the value of this, the only way you could really do that is to combine these things into one term, get all of them into one log. Okay, so first thing we do is we want to combine them, so we need to get rid of that 2. So it'll be log 12 to the base 3 plus log 4 to the base 3 minus log 3 log to the base 3 of 4/3 all squared. I'll expand to become 16 over 9. Okay, it becomes 16 over 9. So now we want to combine this here now into 1. So remember, whenever we add in, we multiply, whenever we subtract in, we divide. So this here now is equal to log to base 3 of 12 multiplied by 4 all divided by 16 over 9. Okay, which becomes log to base 3. With fractions, it becomes 12 multiplied by 4 multiplied by 9 all divided by 16. Okay, so if we simplify that fraction here now, we get log to base 3. This becomes 4 here. Okay, cross this off, this becomes 3. So 9 times 3 is 27. Okay, now some of you might think to stop here, but remember 27 is what? 27 is 3 to the power of 3. 3 by 3 is 9, 9 by 3 is 27. Next step now, we could bring down the 3, bring down the power, so it becomes 3 log 3 to be is 3. So therefore the answer to this is 3, because that is equal to 1. Okay, so whenever they actually simplify something, try to get everything within 1 log and see if you could reduce it to just one number. Okay, so I'll do one more actually for this video. Let's say we have log 27 to base 10 plus log 14 to base 10 minus log 9 to base 10 minus log 7 to base 10 minus log 6 to base 10. Okay, so this one's pretty simple. It have nothing in front of the log, so what we could do is just have to simplify it one time. So it becomes log to base 10. Remember, so we multiply and see what we added. So it becomes 27 multiplied by 14 all over. So notice we minus in a bunch of these things, okay? So we divide them by 9 multiplied by 7 because we minus in it. So remember, we minus in it goes in the denominator by 6. Okay, so let's correct this here becomes 2. Cross this out here, this becomes 3. Cross this out here, this becomes 9. And then this 9 crosses out with this 9 here. So this actually becomes log to base 10 of 1. And remember, log 1 to any base is always 0. So this long expression actually equates to 0. So this was the topic of logarithms. I hope I was able to help you understand how to do questions involving logarithms, and look forward to the next video which covers questions related to the topic of logarithms. Thanks for watching.